In this video, we want to find the asymptotes, if any, of the graph of each of these rational functions. Now, the first thing you have to do is make sure that the rational function is in lowest terms. In other words, if you can factor anything and cancel something out, go ahead and do it. Otherwise, we follow these steps here. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will always be y equal to 0, which is the x-axis. Now, if the degree of the numerator and denominator are the same, like number 2, notice I have an 8x in the numerator, a 2x in the denominator. The degree there is 1 and 1. Those are the highest degree for each expression, the numerator and denominator. So here, it's going to be 2 into 8, and I'll show you why in a minute here. It will be 4. So y equal 4 will be a horizontal asymptote. Now, if the degree of the numerator is larger, like number 3, than the degree of the denominator, you can treat 2 here, up here in the numerator, and 1 in the denominator, then you're not going to have a horizontal asymptote, but you'll have a oblique or slanted asymptote. Now, if it's more than 2, or more than 1 rather, like say this is 3 and this is 1, then you're not going to have an oblique or a horizontal. So let's get started, and then I'll go into more detail as I start to work these. So for the first one, it's already in lowest terms. There's nothing I can factor out or cancel. Degree, if I put an x here, that would have to be 0. And this is 2, so 0 is less than 2. So the horizontal asymptote, and of course these are the equations that we're talking about, is the x-axis, which has equation y equal to 0. So we're actually given the equations of the asymptotes. Now for the vertical asymptotes, you basically look at the denominator, because these are going to come from values for which the function is not defined. So in other words, all you have to do is find the numbers and make the denominator 0 if you have any. And we're talking about real numbers. So we have x squared plus 25. There's no way I can find the value of x to make that 0. Now there are some complex or imaginary numbers that do it, in this case plus or minus 5i, but we're looking for real numbers, so we don't have any there. So for the vertical asymptote, this will be none. And again, if you have a horizontal asymptote, you're not going to have an oblique. So that's what you have for the first one. Now for the second one, the degree of the numerator is 1. The degree of the denominator is 1. Those have the same degree. Then you simply take the coefficient on top, that is 8, over the coefficient of the lead term in the denominator, that's 2. And that's going to give us 4. So the horizontal, the equation of the horizontal asymptote would be y equal to 4. Now for the vertical, again, it's going to come from numbers and make the denominator 0. So we say 2x plus 11 is equal to 0. We solve it for x. So this will be 2x. Take the 11 over to the right. That is adding negative 11 to both sides. I get negative 11 here. Divide by 2. So the equation of the vertical asymptote will be negative 11 over 2. Cancel this one here. Now for number 3, we'll look at that after I do number 4. So let's look at number 4. Q of x is equal to x squared minus 25 over x minus 5. Notice this one factors. As I mentioned earlier, you want each rational expression in simplified form. So if you can reduce it, you go ahead and reduce it. So x squared minus 25 factors into x plus 5 and x minus 5. So this x minus 5 and this x minus 5 will cancel. So this actually reduces to a linear expression, x plus 5. And notice here, we have a restriction. X cannot be 5, because 5 makes the denominator 0. So this particular function is undefined at 5, but x equal to 5 is not a vertical asymptote in this case. So what we do, like if we were to graph this, so let's look at q of x equal to x plus 5. So let's look at this part here. If we place the x by 0, I get 5. So this graph is going to pass somewhere over here. So let's say this is 0, 5. And that's 0, 5 here. If I replace the x by 5, then I get 10. So I would go say 5 over here, and then 10 up. So somewhere over here would be the point 5, 10. But remember, x cannot be 5. So the graph would pass to that point, and it'll skip. So it passes through 0, 5, and then it skips the point 5, 10. So actually the graph, this is really not a rational function the way it reduces, because all it is a straight line with a deleted point. And that deleted point is the point 5, 10. So in this particular case, we have no vertical asymptote, no horizontal asymptote, and obviously no oblique, even though the degree here was 1 more than the degree of the denominator. And of course, the reason we don't have the oblique, of course, this reduces to a linear function or a line. So the best we can say, the graph of this is a line with 1 point deleted, 5, 10. So now let's get to this one over here. The vertical, let's do the vertical first. The vertical asymptote, denominator x plus 4 is 0 when x is negative 4. So again, if you have a rational function and it's in simplified form, then the equations, you can have one or more values and make the denominator 0. In this case, we have 1. X equal to negative 4 makes the denominator 0. Now, if that makes the numerator 0, then you have the same situation as 4. It will be a deleted point. But negative 4 squared here is 16. Put a negative 4 here. You get 12. And negative 10, that's not going to give me 0. So this one satisfies the condition. The function is undefined at x equal to negative 4. So x equal to negative 4 is a vertical asymptote. And because the degree of the numerator is 1 more than the degree of the denominator, we have a slant asymptote. So what we do here, in this case, because the denominator is linear, first degree, we can use either long division or synthetic division. I'm just going to use synthetic, or long division, I should say. X plus 4, go x into x squared is x, then multiply by x here, x times x is x squared, x times 4 is 4x, and then we subtract. So here we're subtracting. X squared minus x squared cancels, x minus a 4x is a minus 3x, and 0 from minus 10 is minus 10, bring that down, and then we repeat the procedure until we get a remainder of 0 here, or the degree of the remainder is less. So let's go x into minus 3. X is a minus 3. Negative 3 times x is minus 3x. Minus 3 times 4 is a minus 12. Subtract here. So minus 3x minus a minus 3x cancels to 0. Minus 10 minus, and this is the minus 12 here. Makes that a plus, so plus 12 and minus 10 is a 2. So this is my quotient. So if I rewrite this, this will be x is equal to x minus 3. And then it's plus the remainder, which is 2, over the divisor, which is x plus 4. We want to know the behavior of the graph as x goes to infinity or negative infinity. So as x goes to infinity, this denominator here gets real large. So this is going to go to 0. This just goes to negative infinity, the same thing's going to happen. This will get large. Absolute value of this will get large, so this will go to 0. And then I'll leave it with x minus 3. So the oblique or slanted asymptote would be y equal to, you simply disregard this. This will go to 0. So you're left with x minus 3. So this one has a vertical asymptote at x equal negative 4 and a slant asymptote at y equal x minus 3. So the procedure to find the slant asymptote, if you have it, and that's going to occur if the degree of the numerator is 1 more than the degree of the denominator. This is 2, this is 1. You simply do a synthetic division or long division. Let me do the synthetic division over here just in case. So coefficient here is 1, and then it's 1 for the x, and then it's a minus 10. We divide it by x plus 4. So it's always x minus the number, so x minus the negative 4. So we put a negative 4 here. If this were x minus 4, this would just be a 4. And this would be, bring this down, that's 1. Minus 4 times 1, that's minus 4. 1 and minus 4 is a minus 3. And minus 4 times a minus 3 is a 12. Add them up, that's 2. This gives me the quotient. And this is the remainder, which of course we got over here. And the degree reduced from degree 2 to 1. So that's why this is x, or 1x minus 3 plus 2. And of course we put it like this, and then this goes to 0. And the slant asymptote then is y equal to x minus 3. And also wanted to point out that that's the reason we can say this if you have the situation as in 2. If the degrees are the same, 1 and 1, we said this coefficient divides that one, and we get the y equal to 4 for the horizontal. And the reason that works is, similar reason here, if I divide the numerator and denominator by the highest degree term, in this case x, divide by x there, it gives me an 8 on top. 2x divided by x is 2. And 11 divided by x is 11x. And we want to know what happens to the graph as x goes to infinity or minus infinity. Well, this goes to 0. So I'm left with 8 over 2. And that's why we set the equation of the horizontal for number 2 was 8 divided by 2, or 4. Thanks for watching. We'll see you next time.